Hello, welcome to Flipped. Today we are on electrolysis of molten binary compound. So if you recall, electrolysis is to decompose electrolytes. And today we are talking about the molten electrolyte first. Okay, so what are binary ionic compounds? Basically, they just consist of one metallic element and one non-metallic element. Okay, one classic example would be NaCl, sodium chloride. Okay, if I decompose this NaCl, it will result in one metallic ion and one non-metallic ion, which are Na plus and Cl minus respectively. Am I right? So this is formed when you melt the solid NaCl at high temperature. This breaks the giant lattice structure, and now the ions are broken the structure is broken down into individual ions, which are free to move about. Okay, so there are positive ions, which are Na plus, and negative ions, which are Cl minus. Okay, positive ions are attracted to and move to the negative electrode, which is the cathode. Okay, this is the cathode, right? Because it's negative, because it's connected to the negative terminal of the battery. Okay, so the positive ions will actually all cluster here. Okay, all the Na pluses will all want to come here because they are positive charge in nature and the cathode is negatively charged. So opposite charge attracts. Okay, and the positive ions, upon reaching here, they receive the electrons from cathode, okay, and they undergo reduction, which is a discharge process. We'll learn about this reduction and oxidation later. Okay, next one is about negative ions, which are Cl minus in the case of NaCl. They're attracted to and move to positive electrode, which is the anode. Okay, I denoted with a A. And at the anode, okay, the negative ions release electrons and undergo oxidation, which is also a form of discharging. Okay, so all the Cl minuses will now come here, okay, and surround the anode. Makes sense, right? Okay, the anode is a positive electrode because it's connected to the positive terminal of the battery. Okay, so this is using NaCl as an example, but this electrolysis will apply for all molten binary compounds which are A plus and B minus. Another example I can give you is MgO, Magnesium Oxide, which is also made up of Magnesium 2 plus and O2 minus. That means it's one metallic element and one non-metallic element. Okay, there are multiple other binary compounds that we can talk about. Okay, but this is just an example using NaCl. Okay, next one is to talk about the actual process, the actual electrolysis. Okay, so this is the electrolysis of molten NaCl using inert electrode. You notice that I have underlined molten and inert because these two are variables that can be changed. And we will examine them in further videos. But in this case, they are molten and inert. And this is actually one of the simplest model to work with. Okay, molten and inert. Okay, let me explain why. Inert electrode means it's either carbon or platinum. Okay, and they do not react with the electrode. So they literally just stay there. Okay, they are, for example, carbon electrodes for both cathode and anode. Okay, they don't react. They are just a platform, a gateway, if you may, to allow the electrons to come between the wire and the electrolyte. Okay, it's like a gateway between the areas here. Okay, so with the electrode out of the way, let's talk about the ions. The ions found in NaCl, okay, at the cathode, what do you think? Okay, so we know that NaCl is made out of Na plus and Cl minus, am I right? Cathode is the negative electrode. So, which one will go there? Na plus. Because Na plus is positive, okay, as we discussed here. Okay, because you can see that cathode is the negative electrode, so the positive Na plus will want to go there. So, naturally, okay, the anode will be surrounded by Cl minus. Makes sense, right? Because anode is a positive electrode, Cl minus being negative charge will be attracted to the anode. Okay, and you can see that there are only one type of ions for each charge. That means our positive charge is only Na plus, negative charge is only Cl minus. So there's no selective discharge. The word selective discharge means that you have to choose. Okay, if I have many cations, many anions, which one do I choose? Okay, this concept will apply later when we in further videos. We'll examine them in due time. Sorry. So what happens here is that at cathode, we have Na plus. Okay, we established that. This reaction happens. Okay, Na plus liquid Okay, it's a bit weird because plus usually we denote them as aqueous, AQ, but in this case it's molten, so it's liquid. Okay, Na plus a electron, because at cathode it gains an electron. Okay, to form Na liquid. This is molten Na, molten sodium metal. You can see that Na plus undergoes reduction to form sodium metal. So this is the reaction that's happening. And the keyword here is reduction. Okay, and the observation is that globules of molten Na metal will form below the cathode. So this is my cathode. You will see some globules will start to form here. Okay, it may even sink down to the bottom. Okay, but usually it will just float around it. Okay, these are the globules that we are talking about here. On the other hand, at the anode side, this one, okay, Cl minus, we established that at anode only has Cl minus, right? Cl minus liquid, okay, same concept here because it's molten. It will form Cl2 gas and releases 2 electrons. That's because Cl minus undergoes oxidation. Okay, so it's opposite of reduction to form chlorine gas. And the observation is that bubbling can be seen at the anode, plus there's a pungent smell. Okay, you can actually see a bit of a yellowish gas coming out. Okay, and there'll be some bubbles here on the surface of the water. Okay, so this is what you'll observe if you were to look at the setup for this electrolysis with molten NaCl using inert electrode. So it's a bit confusing, right? Like how do I know which is oxidation, which is reduction? Maybe I give you a way to remember. It's called ORAC. Doesn't really mean anything. I just call it ORAC for short. Okay, it just means that oxidation always happens at the anode. Reduction, okay, always happens at the cathode. Okay, again, oxidation, the process of oxidation always happens at the anode. You can see here. Whereas the process of reduction happens at the cathode always. Okay, so this is how you can remember them if it helps. Okay, so in a typical question, they usually ask you to name write down the reactions at the cathode, write down the reaction at the anode, and to give the overall equation. What do I mean by overall reaction? Basically, it's to make sure that 1 and 2, okay, this is 1, this is 2, have equal number of electrons on opposite side. Okay, there's a typo here, but you understand what it means. Okay, so what do I mean? So at cathode, let's look at this one again. Na plus 1 electron to give me NaL. Okay, there's 1 electron on the left hand side. This one, 2 Cl minus liquid to give us Cl2 gas plus 2 electrons. So this is not fulfilled yet because in here on the left hand side there's only 1 electron. Here the right hand side only has 2 electrons already. So what must I do? I must, okay, times 2 to this. So I will form 2 Na plus liquid. So I'm just multiplying 2 to everybody here. So give me 2 electrons and 2 Na liquid. Okay, so you can see that this I can name this as equation 3. Okay, equation 3, okay, has 2 electrons on the left hand side, and compared to this one which has 2 electrons on the right hand side. So now they are in some sense equal already. And what do I do next is to actually cancel them out. I cancel these 2 electrons on the left hand side, I cancel these 2 electrons on the right hand side, because I can cancel electrons on opposite sides. Okay, once I make sure that they are equal on opposite sides. So now I just write what's remaining on the left hand side. 2 Na plus here. Okay, 2 Na plus liquid, right? Plus this guy here, because everything is on the left hand side, I just write it down first. Plus 2 Cl minus liquid. Okay, now ignore my 2 EUD because it's already been cancelled with this guy here. So now what's on the right hand side? I have 2 Na liquid. Okay, plus this guy, right? Cl2 gas. Okay, so this will actually be you might think this might be all, but actually it's not over yet. Okay, there's one more step, because you can see that they can combine. Plus and minus can actually combine. This only works if they are on the same side of the reaction. If there's a plus on the left hand side and there's a minus on the right hand side, they cannot combine. But in this case, they are on the same left hand side, they can combine. So now it's 2 NaCl, okay, and make sure that the states are the same. before they can combine liquid to give us 2Na liquid plus Cl2 gas. Okay, so that's how it's being done. Let me just do a recap for this overall equation. It may be a bit confusing. So we have established what's the cathode reaction here, what's the anode reaction here. Okay, the only requirement here is to make sure that both the cathode and anode reaction has the same number of electrons, okay, in their own individual reaction. So in cathode, at the left hand side, there's only 1 electron. In anode, there are 2 electrons already. So to make sure that they have the same number of electrons, I multiply 2 to my first equation, such that this equation now has 2 electrons. You can see here. Okay, but by multiplying 2 to this electron, I must multiply 2 to everybody, because it's not fair, right, to just change the number of electrons without changing the other substances, other species. So when I multiply 2 to everybody, I get this one, 2Na plus liquid plus 2 electron plus 2Na liquid. But now, what I want to do is I want to cancel out the electrons on both sides. That means to cancel out electrons here and to cancel out electrons here. After that's out of the way, I just write in what's on the left hand side, in this case Na plus and Cl minus here, and right hand side 2Na and Cl2 here. And I just write this down together. But then I realized these two can actually combine because they have the opposite charges and have the same state. Okay, both liquid. So I can combine them to 2NaCl, and the right hand side I just copy back the same species here. And overall equation really just means what is happening overall. Okay, what's this reaction happening overall? You can see that it actually matches what we want to do. Molten NaCl breaks down into 2Na liquid, sodium metal, the globules that we talk about, globules here, and the Cl2 gas that's being evolved. Okay, and you can see the bubbling of the gas at the anode. Okay, so essentially this is telling you what's the end reaction, skipping all the mini steps which are showing the electrons, all that. Okay, so this is and that's why it's called an overall reaction. Okay, and that'll be all for electrolysis of binary compounds.